We will wrap up our study of statistics here in section 12.4 with the normal distribution. Now, have you ever been so lucky as to have been in a class where the teacher grades on a curve? I'm guessing it wasn't a math class. Now, what kind of curve were they using? Very likely it was a bell curve. Now, even though we don't grade on a curve in math class, we get to learn about the bell curve. Data that fits the bell curve is said to be normally distributed. The mean, median, and mode of a normal distribution are all equal, kind of like the bowling scores that we examined in the previous section. Test scores, average height, gestation periods, all of these are examples of data sets that are normally distributed. So what exactly does that mean? The bell curve is a curve whose shape resembles a bell. So to understand this, we can take our data set and we can organize it from smallest to largest on a number line. And then we can plot that versus its frequency, or how often those particular data points occur. Remember, this is where we started our studies of statistics. We were making histograms. So for example, let's suppose I make a histogram for my data set, plotting the numbers versus the frequency, and the shape looks something like this. This is what we call discrete data. That is, the data points are distinct and there are distance between the data points. In this case, we get a jagged staircase looking shape, which resembles the shape of a bell. Now, if I were to take these data points and I were to connect them with a smooth curve, I would end up what looks like the shape of a bell. Think about ringing a bell, right? You have something that looks like this. So we're looking at the shape of a bell as matching the shape of the distribution. Again, histograms are great ways to visualize the shape of a discrete data set. If the data set, on the other hand, is a continuous data set, for example, the heights of humans, right? We can look at the lowest to the highest and every single point in between. We're dealing with what's called continuous data. And in that case, the shape more obviously resembles a bell. The bell curve is centered around the mean. Now, the way that we interpret this is as we move further above the mean or we move further below the mean, there are fewer and fewer data points as we move away from the mean. So, for example, if we're looking at grades being distributed in a classroom, the mean is, of course, in the middle, and there are fewer students that have those really high grades, and there's fewer students that have those really low grades. So if your teacher happens to grade on a curve, then most of the students will tend towards the middle, and that's right there at that average of C. Then fewer will receive Bs, even fewer As, and fewer Ds and fewer Fs. So most of the data is right there in the middle. This is what we call the normal distribution. If you look at the average height of humans walking around there, have you noticed that we're all sort of about the same size? Absolutely, because height of humans is normally distributed. That is, most of the humans tend towards the center, towards that average height, and you have fewer and fewer individuals that are extremely tall or on the extremely short side of things. So if a curve resembles this bell curve, we say that it is normally distributed. And this is what we're going to be analyzing in this section.